A warm welcome to everyone. Let us focus into the perspectives of osmotic dehydration using functional ingredients as osmotic medium in the field of food preservation. In the modern era, people urge towards the consumption of better foods for better lifespan. The concepts of functional foods have been arrived. Almost all plant based and animal based foods contain various levels of bioactive components and wider chemical composition with unique therapeutic significance. In the emerging trend, consumers with increased awareness on health, consumption of potentially healthy foods have been practiced. In addition to that, consumers view on saving money and time. Ready to eat foods have been popularized in the market for instant preparation of foods. Those instant foods developed with the assistance of several dehydration techniques such as osmotic dehydration and several mechanical dryers for better quality of food products with extended shelf life. Since osmotic dehydration has been accepted as a potential pre-treatment technique with prior to mechanical dehydration of foods for the impregnation of physiologically active components into the tissue matrices of plant cells. Therefore, the chemical composition of the tissue enriched with bioactive components and also nutritional and sensorial as well as the functional properties of the foods have been enriched without changing its integrity. Thus, it paves the way for other processing techniques such as freezing, freeze drying, vacuum drying, and sun drying, etc., which can offer the greater keeping quality free from any kind of microbial deterioration and enzymatic destruction. Osmotic dehydration has been employed as a better food preservation technique both at the international and national level scenario in terms of food preservation right from few centuries ago. Osmotic dehydration, as we all know, that is a general phenomenon in which partial dehydration of water from foods happened and instantaneously impregnates it with solutes that modify its functional, structural, and nutritional properties. In the global scenario, various osmotic agents like glucose, fructose, high fructose corn syrup, sodium chloride, sucrose, and such combinations have been used for osmotic dehydration process. The shelf life of the product is thus highly improved due to the efficient moisture removal with the lowest water activity at which physicochemical, nutritional, and microbial deteriorations are found retarded. And also, the implication of this technique for the infusion of bioactive constituents in the tissue matrices of certain plant-based foods and observed significant results where the researchers carried out at international level and national level. A glimpse at the infusion of bioactive phytochemicals in the tissue matrices of coconut slices is done where the extracts of plant-based produced that is used as osmotic medium, which is expressed here. The curcuminoids infusion in coconut tissue matrix where the source is turmeric, and the menthol infusion in coconut tissue matrix and the source is mint leaves. The carotenoid infusion in coconut tissue matrix and the source is carrot. The gingerol infusion in coconut tissue matrix, the source is ginger. The betanin infusion in the coconut tissue matrix and the source is beetroot. And the flavonoid infusion in coconut tissue matrix and the source is pineapple. Since many eminent scientists investigated the mass transfer properties exist during the osmotic dehydration process such as weight reduction, solid gain and water loss, and such type of mass transfer characteristics that have direct relationship with the product shelf life and quality. It is concluded that the osmotic dehydration is employed for the quality improvement of foods in terms of color, flavor, texture, taste and appearance. It requires very less amount of energy and the packaging and distribution cost of the products also found to be very less. There observed the significant retention of nutrients during storage period, and there is observed the retention of volatile flavors and reduction in tissue damage of the osmotic treated foods on comparison made with conventional air drying and sun drying processes.